Hey there, Mr. Sutton here, bringing you the Pre-Cal Honors 4-4 Extra Practice 3 Part 2 solutions. We've got another puzzle that goes with this one. Let's check that out. So this is the second puzzle on this one worksheet. We're answering the question, is the ln function a log function? So we basically, for the first several questions, 19 through 23, just have to match the equation with the solution and then put the letter next to that number down in these boxes below. And then for the last four questions, we're matching the function with the correct graph. So let's get on our way and see where this leads us. So here we go with number 19. We've got e to the x minus 1 equals 0. To solve this, I'm going to get the exponential term e to the x by itself by adding 1 to the other side. And then to undo e to the x, I can take the ln of both sides. Taking the ln of e to the x just gives me x. Taking the ln of 1 is going to give me whatever I have to raise e to get 1. That would be e to the 0. So we're going to write 0 for my x value here. And that matches L, which I'm going to then put in spot 19. For number 20, I've got ln of x minus 1 equals 0. So let me now get my logarithmic term, ln of x, by itself by adding 1 to the other side. And I can get rid of the ln by raising the base, which is e, to both sides. So I have e to the ln of x equals e to the 1. E to the ln of x is just going to cancel ln out, giving me just x over here. And then we have e to the 1 over here, which is just e. So x equals e, that's going to be choice A, going in spot 20. For 21, solving this equation, I have two things being multiplied with a result of 0. I can use my zero product property on this to set each of these factors individually equal to 0. So I can write x equals 0, because 0 times whatever is going to give me 0. And I can also try to write e to the x equals 0. The trouble, though, is that e is a positive number, it's non-zero, and no matter what you raise a positive non-zero number to, you're never going to be able to get 0 out of that, because you're just multiplying positives together. So this is a dead end. I don't get any solutions out of that branch. But I do still have e to the 0, which is L, and that goes in spot 21. For this one, I have to take the ln of both sides to get rid of the e. So ln of e to the x is just x, and we have ln of 2. ln of 2 then is going to be my x value, which gives me r for the answer. Put that in spot 22. For 23, I've got 5 to the x equals 2. I'm going to get this x out of exponent land by taking the ln of both sides and using my pop-out rule. So the ln of this left side here is going to let me rewrite that as x ln of 5. And then I have to take the ln of the other side as well. So I just have ln of 2 over there. To get x by itself, I just need to divide both sides by ln of 5. So I do that. And I have ln of 2 divided by ln of 5. Now, none of the answer choices are decimals. So I can just leave it in this form and just make sure I find it over here. That's going to be choice T, which gives me a T in spot 23 right there. For the next four questions, I just have to match the function with the graph. So first they give us kind of the easiest one, f of x equals e to the x. This is just going to have my standard exponential look, starting low on the left and moving right and up into infinity with that horizontal asymptote on the x-axis. So n matches e to the x, so that goes in spot 24. Next up, number 25, we have e to the negative x. Now the key on this is recognizing that since I'm negating the input variable here, I'm doing a horizontal left-right reflection of the original function, e to the x. So here's e to the x. I just need to flip that over the y-axis. So that's going to end up giving me choice y over here, which I'm going to put in spot 25. For this next one, 26, e to the negative, or actually negative e to the x. Since my negative is now outside the function, this is a vertical reflection. I'm going to be taking e to the x and flipping it over the x-axis. So again, here's e to the x. It was that choice n. I'm going to reflect this vertically. That gives me this upside down version over here, u, and that's going in spot 26. And finally, final boss battle here, ln of x. Well, there's only one left, but just kind of logically talking about this, ln and e are inverses. Since we have an inverse, we have to do a y equals x reflection of the original to get the graphical inverse. So basically take this e to the x and flip it over the line y equals x, a diagonal line that goes through the origin. So if I flip that over, that is going to end up giving me choice A for that last one. And now solving the riddle here, is the ln function a log function? And the answer is naturally. Get it? Because ln is the natural log. All right, till next time, Mr. Sutton signing off.